In this video series, I'm going to talk about a couple of algorithms, and I will start with a Bubblesort algorithm. It's a simple sorting algorithm. And what we are going to do now is we will sort this list, and the list in the end it will look like this: 5, 4, 3, 2, 1. So starting with the biggest value and ending with the smallest value. And in Bubblesort, what we need to do is we need to compare the elements for so in this case we would need to compare the 3 with the 4, and if this 4 is bigger than the 3, then we will swap these values. So that means we will need a loop, and we will use this piece of code as our starting point. So when the value, in this case in the first iteration, then when the value 4 is bigger than the value of 3, then this is true, and we can swap the data. And yeah, now we will start. So j holds the value 0. Oh, and this is also important, len data minus 1, because we have j plus 1, otherwise we would be out of the range from this array. So we need to decrease the length by 1. And j holds the value 0, j plus 1 holds the value 1, so that means the element 0 holds the value 3, element 1 holds the value 4, and now we will compare these values. So if the value in element 0, so the 3 is smaller than the value in element 1, the 4, so 3 is smaller than 4, 4 is a bigger value, and that means then that we need to swap these values. And that looks like this. So this is a list, holds the values 43152. Then the list keeps counting, and we will increase j by 1. So j is 1, j plus 1 is 2. Compare the elements again. Element 1 holds the value 3, element 2 holds the value 1, and the 3 is bigger than the 1, so that means we don't need to do anything. We can keep everything as it is. So nothing has changed. J goes up again. J holds now the value 2, j plus 1 holds the value 3, and we compare again the elements. Element 2 holds the value 1, element 3 holds the value 5. We swap the values, and then it looks like this: 4, 3, 5, 1, 2. And again we increase j. J holds the value 3, j plus 1 holds the value 4, and now we can see already that we went through the whole array. Let's first compare the values. So we compare the 1 with the 2. 2 is a bigger value, so that means that we already can swap the data again, and the array will look like this: 4, 3, 5, 2, 1. And this is also interesting. This is, of course, this is the smallest number in the whole array, and that means that we don't need to touch this number again. What that exactly means, we will see that later. Okay, so we went through the whole array, but it's still not sorted, and that tells us that we will need another loop. So we will just add now another loop, and then we will do the same again. So that means it would look like this. We will just add another loop with a variable I. And if we would have had this loop at the beginning, of course, I would have held this value, I equals 0. Okay, so in this case now, we went through the whole array, and that means we need to sort the data again, and that means the variable I goes up to 1. And yeah, j, again it will start at 0, j plus 1 will start at 1. And now we will compare the elements again. And 4 is bigger than 3, so we don't need to change anything. So 4, 3, 5 to 1. J goes up again. J goes up to 1. J plus 1 goes up to 2. And we will compare the value, the data and element 1 with the data and element 2. And the 3 is smaller than the 5, so we can swap these values. And the list will look like this: 4, 5, 3, 2, 1, or the array. And j goes up again. J holds the value 2. J plus 1 holds the value 3. And we compare again the values. And 3 is bigger than the 2, so we don't need to swap anything. And j goes up again. J holds the value 3. J plus 1 holds the value 4. And yeah, 2 is bigger than 1, and that means again we don't need to swap anything. And we went again through the whole list, and that means this variable, it will go up again, so I is equal to, and now we can compare the values again. So element 0 holds the value 4, element 1 holds the value 5, and 5 is bigger than the 4, so we can swap the values, and the array is now sorted. It holds the value 5, 4, 3, 2, 1. And this is then already the whole code. Yeah, this is our variable 1, and this just tells the algorithm how often we need to go through this list until it's sorted. And here we have j and then the length data minus 1. You've seen that already. The comparison, you've seen that already too. And what we're going to do now is we need to swap the data. So what we are going to do now is we will save the data from data j, and so maybe we can just use this as an example. So variable I is 0, j is 0, this one is 0, j plus 1 is 1, and data j holds, in this case, a value 3. So the value 3 goes to this variable to save value, and then we will move the value data j plus 1. So this points to element 1, this one. So that means that we will move the value 4 to data j, and data j points to the first element of the list. And that means at this point the list would look like this. And now we need to restore the value that we have overwritten. And that means we will use the saved value, and we will restore the saved value to data j plus 1, and that means j plus 1, it will then hold this value as 3. And yeah, then the numbers are swapped, and that is basically already the whole logic. There's an optimized version where we can see minus I, and that is what I said already. if a value is already sorted, then we don't need to touch it again. Like this one. So it wouldn't make sense to iterate through the whole list, because if we know that this value is already sorted, then we just need to go from element 0, in this case, to element 3. And then later, when it's at some point the 2 is sorted, and then we will go from element 0 to element 2, and so on and so on. And yeah, that will improve the algorithm, so it will be a little bit faster. I mean, in the end, a bubble sort is not a fast sorting algorithm, but yeah, anyway, that would be the optimized version. And here's a version that's more Pythonic. So instead of spinning 3 lines, you could do all this with just 1 line. And now we just execute the program, and here we can see that the values are sorted. And of course we also can just sort it in the other way, starting with the smallest number, and as output is 1, 2, 3, 4, 5. And yes, that's everything for now.